This is Mr. Bear, and I'm going to show you how to balance a more difficult chemical equation than the ones you've learned how to do in class. One of my tips to help you balance a chemical equation to follow the law of conservation of matter is to identify polyatomic ions. So what I'm going to do is underline what looks to be a polyatomic ion. That looks like nitrate. Looks like I have just one of them there. There would be more than one nitrate if there was a parentheses around it and there was a subscript right next to it. Turns out I have nitrate on this side as well. Looks like I also have sulfate on this side and sulfate on that side. When you have a polyatomic ion that's being represented on both the left side and the right side, when you do your inventory to count how many you have on the reactant side versus the product side, keep it together, keep it whole. So we have one silver here, we have one nitrate, we have two sodiums, and we have one sulfate on the left side. On the right side, we have two silvers. As far as nitrates, we have one. For sodium, we have just one. And for sulfate, we have just one. Okay, my tip is to make the odds even. So it looks like for, let's see here, in particular for sodium, or I could have started with silver. It doesn't matter which one I begin with. If I start with silver, it looks like I created a silver atom. I had one on the reactant side. Now I have two on the product side. So I have to make this 2. I can't go in here and put a 2 right there as a subscript. That would be wrong. The reason behind that is because silver has a positive 1 charge and nitrate has a negative 1 charge. So the ratio between those ions is 1 to 1. I can only adjust how many silvers I have by putting a number in front. And the numbers you put in front have a name called coefficients. So I need to make this 2, so I'm going to put a 2 in front. Now, it doesn't become 2 plus 1. That would have made that 3. The 2, the coefficient in front, multiplies everything after it by 2. When I say everything after it, I'm referring to just the silver and the nitrate, not the sodium and the sulfate. That's a separate compound. I'm talking about just this compound when I put a coefficient in front of it. So the 2 times 1 is 2, and now I have 2 nitrates. So I've balanced my silver, but I haven't balanced my nitrates because they're now out of balance. So now I need 2 nitrates on the right side. So I'm going to go over here, and again, I can't put a 2 here. I can only adjust how many I have by putting coefficients in front. So I'm putting a 2 in front. Now I have 2 sodiums. I now also have 2 nitrates as well. So now my silvers, my nitrates, my sodiums, and my sulfates are balanced. This equation's correctly balanced. It's 2 silver nitrates for 1 sodium sulfate react together to produce silver sulfate plus 2 silver nitrates. Notice this adjusts how much of them I have involved in my chemical reaction. Now, this one's challenging only in the respect that we have these things called polyatomic ions that you keep together. So now I'm going to do another more difficult chemical equation to balance where you don't have polyatomic ions. This one is CH3 NH2 reacting together with oxygen to produce CO2 plus H2O plus N2. So when I look at this, I don't actually have any polyatomic ions at all. So when I look at this, I have to break down each compound into the specific elements that make it up. So when I look at this compound on the left, this one's particularly tricky, and you probably notice this because the hydrogens aren't kept together. The reason the formula is written like this is because it gives a hint to any person about what the Lewis structure would be for the compound. And this is the Lewis structure for that compound. So that's why they keep the hydrogens separate, and it's to show that the hydrogens are bonding to the nitrogen and not to the carbon. So anyhow, when I do my count, I'm going to have carbon, I'm going to count hydrogens, I'm going to count nitrogens, and I'm going to count oxygens as well. So this is my inventory, and let's do a present count of how much I have. So I have 1 carbon, I have a total of 5 hydrogens, I have 1 nitrogen, and I have 2 oxygens on the left side. On the right side, I have 1 carbon, I have 2 hydrogens, 2 nitrogens, and 3 oxygens because I have 2 here and 1 there. So this is my second tip for today. Not just the polyatomic ion need to be kept together, and we don't have polyatomic ions in this one, but see this one in particular and this one in particular. See how they're entirely by themselves and they're not bonding to any element different than themselves, these are the ones that I want to balance last. So for oxygen and nitrogen, these two in particular, I'd like to balance these at the end because I can easily adjust them into anything I want. So I'm going to actually start with the carbon and the hydrogens. So when I look at the hydrogens here, I've got 5 here and I've got 2 here. My recommendation is always to make any ones that look scary, like this compound right here, into even numbers. So I want to make this into an even number. That means multiplying it by 2. So I'm going to put a 2 in front. And now I don't just have 3, 5 there. I now actually have 10. I also adjust the number of carbons. I now have 2. And I also adjust the number of nitrogens. I have 2 there. Notice that by balancing the hydrogen, or making the hydrogens even, I also incidentally balanced out the nitrogens as well. So now I need to make sure that my hydrogens are the same on both sides. So I've got 2 hydrogens over here. I need to have 10. So I'm going to multiply it by 5 by putting the coefficient of 5 in front of the water. And when I do that, I get 10 hydrogens. But unfortunately, my oxygens change considerably. I have 5 there, and then I have 2 there. That actually leaves me with 7 oxygens. So always make sure you do the count. Now I've got my nitrogens balanced. I have my hydrogens balanced. Let's work on, I could work on the carbon. Remember I said leave things like the nitrogen and the oxygen to be balanced at the end. So for the carbon I have 2 over here, I need 2 over here. So I look to see where I'm going to put my 2 as a coefficient. I'm going to have to put my 2 in front of here. That changes my number of carbons, so now I have 2. But it also changes my number of oxygens, so I have to recount all of my oxygens on my product side of this equation. So 2 times 2 is 4, 5 times 1 is 5. So 2 times 2 is 4, 5 times 1 is 5. Add them together, you get 9 oxygens. So now my carbons, my hydrogens, my nitrogens, my oxygens are the only one not balanced. See this right here? So this is the last tip I'm going to give, and this is going to be one of the best ones you can learn from. I need to make this oxygen into 9. If I want to make this oxygen into 9, I'm going to have to multiply it by a coefficient to make it 9. The only coefficient that I can multiply this by to make it 9 is 9/2. I can actually multiply things by fractions, particularly with 2 in the denominator spot. 9/2 times O2, 2 oxygens, gives me 9 oxygens. Now, technically, you could actually leave your balanced chemical equation exactly like this, but that's usually not the form that you see in most chemical equations. So I'm going to rewrite it. I'm going to show you how to modify your chemical equation that is technically balanced, but unfortunately we have a fraction in front of one of our chemical formulas, and we want to get rid of that fraction. So now I've rewritten it. What I can do is I can multiply this coefficient by a number to get rid of the 2 in the denominator spot. If you're already thinking in your head that it should be 2 that we multiply it by, you're correct. But if I multiply this coefficient by 2, I have to do it with all the others. And that's because I have to keep the ratio of every atom for every element, my balanced equation, the same. That way my elements stay balanced. So if I need to multiply this by 2 to get rid of the fraction, I have to multiply this by 2, that by 2, this by 2, that by 2. You can think of it as this, just like the distributive property in math. So the correct balanced equation is 4CH3 NH2 plus 9O2 produces 4CO2 plus 10 waters and 2 nitrogens. And that's the correct balanced equation. Although, like I said, you could technically leave it with a fraction, but that may not be what's asked for in most chemical reactions that you write out. Another one I just want to point out is, say you're trying to balance the reaction between hydrogen and oxygen reacting together to produce water. Well, if you do that, and say you accidentally have a 4 here, and because you had a 4 there, you have a 2 here, and then you have a 4 over here. Notice how every coefficient is divisible by 2. That means you should take all of them and divide them by 2, because the correct ratio is the lowest ratio. So the correct equation should be 2H2 plus O2 produces 2H2O. And we never write 1s. Notice there's no 1 that we write as a coefficient in our chemical equations. If you have any other questions, please see me for tutoring.